Hello again, guys. If you saw my previous video, I have a little request for you. Maybe for like a second, just forget about this thing and pretend you have no idea what it is. And if this is your first video that you're seeing of, or first video of mine that you're seeing or whatever, then you'll find out what this is. What this is it's called an InStoreMercial, as you can tell by the front, and it's set up to play a little video in like retail stores, and it'll I guess play a video of whatever product it is they're advertising. It sits there, and you can kind of see that this LED is flashing, so you would hit that play button and then it starts playing the video that's stored on a little SD card, which is inserted in that slot there. I mentioned in the other video, but I think it's kind of sad because these are kind of like meant to be disposable, and I got it from a store that was just going to chuck it. And the biggest reason why I wanted it is because I had a feeling that the LCD used in this device was probably some sort of kind of like off-the-shelf unit, and it wasn't going to be like some total custom job with like its own like serial protocol or whatever. And when I opened this up, sure enough it was, but I had to fix it, as I showed in the other video, because my kid managed to get a hold of it and tear apart the ribbon cable. Alright, so since I had already taken it apart, I can kind of show you guys how to open one of these in case you manage to get your hands on one. It had these screws right here that were bolted onto, or that were screwed onto some nuts, but those aren't actually being used to keep the unit like intact. Here in the back, it had a screw that holds the whole battery compartment in, and then you gotta like undo this little clip right here on the side, and then the whole battery compartment just comes out, which is this right here, which they're calling a smart pack, and it's got 6 AA batteries. I made the mistake of assuming that because it used 6 batteries that there was 9 volts, being output from the connectors here on the end. Turns out that it's actually 4.5 because there's 2 sets of 3 batteries in the series, and then both of those sets are connected in parallel. And that's the inside. So they just try to make it so that you don't have to open up the back or whatever and remove the batteries. So back to the main unit here. On the back, there's no other screws. It's just that one to remove the battery pack. So what you end up having to do is you got to peel off this thin plastic covering here in the front, the one that like protects the LCD, and it's got these cutouts for like the speaker and the button there. And if I could get to it, that would be cool. Even though I've taken it off before, it's actually stuck on there pretty well. Like that double-sided adhesive is really sticking to it. So there we go. Managed to lift it up. So then this comes off, and this you can just like peel all the way off. And then there was a few more screws in here in these holes, and then there's a couple more, or 3 more right here in these. The ones that are in the outer holes were to hold this back section in place, which is the one that the batteries slide into. So when that comes off, and then the other 3 were just to hold this plastic piece. I'm guessing what it is that they probably have like different backs to it for like different functions. Like maybe there's a particular unit that doesn't have the batteries in it and just uses power connected here, so they can make it a little bit flatter or whatever. Because it's also got these holes right here that apparently can mount to something, and it's got like these little ridges, so I'm sure there's some different mounting options for this whole unit. There's a speaker, and there's a button, as we can see. There's the LCD. And so once we had removed those other 3 screws, then this piece can come off the back like that. It just kind of lifts up. I'm going to be a little careful here because I don't want to damage the LCD ribbon again. But inside there would be the board, and this board was originally, I believe, permanently attached to this the back part. I'll show you guys how that was actually done. But then we could just kind of like lift it up there and tilt the LCD up and undo this flat flex connector here, and that allows the LCD to come off, although the speakers were still like soldered to down here where the speaker output is. And there's a little audio amp that I fried by incorrectly assuming that this unit used 9 volts. It just immediately went up in smoke when I hooked up power to it, although it took me a second to figure out where the smoke was coming from. Fortunately, the rest of the unit survived, and it still works, as you could tell. It still plays the video. There's just no audio because I burned up the amp. So once we've taken off the speakers and the LCD, then there's 2 more connections here that are the ones that go to the contacts for the battery down here. This little, it's sort of like a little pin that was sticking up here was like melted, and that would just kind of help hold the board down to this back plastic, the back plastic piece. Up here on the top we have buttons for up and down volume. There's the button that actually gets pushed in when you hit that play button, and there's the SD card that holds the video. There's really not a whole lot in here. We got this a RAM IC right there, and then this is the main ASIC. It's got APM 50063.1 on the chip there, but trying to look that up, doesn't really come up with anything online. But I mean, unless they totally went and did like a custom job, that's probably like some like another off-the-shelf chip or whatever that they've just rebranded. Maybe is like maybe some sort of like a generic media player chip. So once we've gotten this far and we've removed this board from this back plastic piece, we're greeted with this lovely message in the back. Check it out. If it would focus there, it says "Wow Factory." I'm guessing that's Shenzhen Company Limited. It's our technology pitch. So I just kind of looked at that and I was like, what? It took me a second to realize that that's actually what it said. I thought it was like maybe some numbers or something, but yeah, that's I'm guessing they're making it pretty clear that it's their stuff. So yeah, whatever. So 2 of the things that I wanted to figure out was first of all, the LCD pinout, which I think shouldn't be very hard to figure out at all because it's just like a few power pins. We know that 2 of the pins are, at least 2 of these pins are being used for the LED backlight, and then there's a total of like 24 traces that appear to be for color, and we're gonna see about that. We're gonna try to figure it out. And then there's like 5 other lines that are apparently the control lines, and as I mentioned, I'm not totally sure if this is using I2C or SPI for control of the LCD, but for the most part, for like the color data and all that stuff, I'm pretty sure it's just parallel, a 24-bit. This little section up here has the driver for the LED backlights, so that's what that is right there, and it just gets like 5 volt or 4.5 volt, and it feeds straight into that drives the backlights. I'm sure it's got a line that controls the enable, and there's a real-time watch crystal there. That appears to be some sort of a little EEPROM. There's the RAM. It appears to be a Micron. I think it's Micron, and it's a 48LC4M16A2. I don't know how big that is. I haven't looked it up. There's a few other things going on around here, which are probably part of the regulator for like these 2. And there's the SD slot. It'd just be using like the SD of the MISO and the MOSI lines going out from that. Here's some diode, which I'm assuming is probably for protection. Not a whole lot else going on here. There's a couple of little surface mount LEDs right there. Oh, and another thing that I thought was kind of interesting is that down here, I mean, it's a little cut off because of the little VIA right there, but I think it says USB 301. So apparently it looks like this is supposed to be some connector for USB, although it's got these 2 resistors right here that aren't populated. So I thought we'd try to add like a little connector here and maybe like put 2 resistors across there. I don't know what I'd use just yet. Maybe some like low value, like 100 ohms or something, just to test it out. And we'll hook it up to a little netbook that I have right here, and we'll see if it does anything. There's also another unpopulated slot up here that says update, which apparently seems to be like some sort of a push button. So I think maybe we'll just if we do hook it up to USB or something, we'll jump these and see if it does anything. There's another unpopulated spot here that says J1, although I have no idea what the heck that's supposed to be. Other than that, yeah, not much else going on up here. And as we saw in the back, not a whole lot else going on there except for like a bunch of like test points. So as far as the LCD goes, on the back here, it's got a printing that says OTA 5180A-C3, and I tried to find some information on that, and it turns out that that's not the model number of the whole LCD unit itself. That's actually the number of the IC that's on the that little chip that's on the actual LCD itself. So we have the data sheet for that, and then I thought that the number that was up here, I mean, it's kind of gone now because I had to fix it, but I thought maybe that number there was the actual model number for the LCD, since this one brought up nothing, or I mean didn't bring up like the whole LCD unit itself. But nah, I couldn't really find anything with that number on it. Alright, so here on the main board we have a silk screen that says FGD 430A 4005, and that actually did bring up something, and I found some website where it actually shows a picture of a pretty similar looking LCD unit, and it says that it's like 480 by like 272 pixels, which is, I mean, it's not awesome or anything. It's not like terrible either. So I don't know, maybe I figured, you know, like you could use this LED for, or this LCD for, you know, some other project, and that's kind of, as I mentioned at the beginning, kind of the reason why I wanted it. Regarding the SD card, I mean, it looks at first glance like a normal SD card. You know, it's got like this the Write Protect little slider here on the bottom. You know, it's got all the usual contacts. But I've noticed that it appears that there was like kind of something dark right there with, it looks like contacts. Upon closer inspection, it actually looks like it's a micro SD card right there that maybe like a little breakaway. I doubt that they'd really be using some sort of adapter, you know, up here. So I thought we'd open this up too and take a look inside and see what they're actually doing there. It could be that this is like one whole board, and then, you know, it's just kind of like a little bit of perforation right there, and they can just break it off so that the same SD card could be used in like a different unit or whatever, maybe something a little bit more compact. So we'll cut this open, since I'm not really too worried about keeping this intact. It's not like I want to be watching this commercial over and over and over again, you know. So coming back to the LCD here, we know that the two all the way to the far left here, pins 1 and 2, are for the backlight. So, you know, that's pretty clear here. And then the next one, pin number 3, isn't used. Pin number 4, by tracing it out on the main board here, it turns out, well, if we go to the back, it turns out that that's one of the power inputs, which is this trace right here, and it's got two little vias that go to the other side, and those appear to correspond with, well, one obviously corresponds with pin number 4, and then the other one seems to go over here to 30. So I guess pin number 30 right there would be another. I'm assuming it's 3.3 volts. I haven't actually measured yet, but so yeah, so these two right here are tied together, and those are apparently just for power. And then we have the 8 that appear to be for all the color bits for one color, and then we got the next 8, and then the next 8. Quick and dirty way that we could find out which color is what is to try to like ground these lines as it's working, and just see, you know, like which color kind of like fades out, whether it be blue, green, or red. So it's probably not the best way to do it, but we'll just try that out just to mess with it. I mean, if anything, the only thing we're going to damage is the actual like video chip itself, which is by itself kind of useless. I mean, it's not like I can really do much with it. It's already pre-programmed to do what they programmed it to do. And apparently, I found their website. They have a few, you know, details about these devices, and it's supposedly the video is encrypted or something, because I stuck that SD card in a computer, or like a SD card reader, and I tried it on like a couple different computers, and it won't read it. It shows up like it's unformatted. I don't have like a Linux PC or anything to hook it up to see if I could figure out what's on it, but yeah, just off the bat, I couldn't really read anything on it, so I have no idea what, you know, format the videos in or whatnot. So after the 24 bits of color here, then we have the ground, which is that right there. So apparently this whole thing is just using one ground for everything. And then the next 4 after that power trace right there apparently should be for the, according to the data sheet, it's probably using an SPI interface. So there's 4 there. One would probably be chip select, and then we're going to have the SDA and then the SCL, which leaves one more pin to do I don't know what, because apparently the controller chip that's inside of here also has like a VSync and an HSync line and like a dot clock, but there's a bunch of pins, or I mean there's like 2 other pins here that aren't being implemented, so I don't know exactly how it's doing that. Maybe it's just programmed to, you know, just like scan in one direction, so it, you know, the LCD has to be in like a certain orientation for it to, you know, be right side up, because sometimes like on a lot of LCDs like this, you know, you have the option of which way you want it to scan the image. So I don't know, maybe they already have that preset. We'll poke around with the scope on some of these pins, you know, and see what they're doing, find out which one's like the clock for the like the SCL and the SDA and the chip select and all that. Oh, and in case you haven't noticed it, right here on the back of the LCD, there's this little kind of like dark spot. That's a spot, or this area right here kind of like sat right above that amp. So when it went up in smoke, it stained the back of that LCD. Alright, so I've got power applied to this unit now by way of the connector here, and I'm just feeding 4.5 volts into it, and as we can see, it's working just fine. So we verify that that's working. So now we'll have a poke around in there and we'll see what kind of things are going on those pins. And whoops, I think I just shorted the power, but no worries, it's still working. Okay, so first things, let's see what kind of voltage we're getting to the LCD. We're going to test this point right here. And apparently it's looks like it's only supposed to be 3. So that's a 3 volt line, and then the other 3 volt line going to the other side. I kind of don't think that it would actually be 3. It's supposed to be 3.3, but for whatever reason it's not actually getting 3.3. But I guess that doesn't really matter too much. It's working just fine, so that's okay. The rest of the other lines here, we're going to have to use the scope to see what's going on with those. Hey, one thing I didn't know is that apparently when it's got power hooked up to the jack here, the video just continuously loops. You don't have to keep pushing the button. So that's kind of helpful. So I've got this test lead here hooked to ground. We're going to ground out some of those lines that appear to be for the colors and see, you know, which color's affected by grounding out which pins. Conveniently enough, there's actually all these test points right here that go to the LCD connector. So that'll make it pretty easy. Let's start here. I'm kind of having a hard time, so I turn off the lights so that, you know, it'd be a little bit easier to see the LCD itself. But let's see what is affected when I start touching some of these here. Okay, the image turns a little more blue with that one. Way more blue there, so it looks like these might be for the red. That one doesn't really do much. It seems like when we touch the higher bits, that's when it gets darker for that particular color. This one here looks like it might be affecting the blue. Yeah, so it looks like it goes red, green, and then blue. Okay, I'm going to try to poke the 6th line in from the end of where pin 40 is. As we remember, the first 4 are for the touch panel, and then it skips 1. Does it skip 1 or 2? It skips 2. So it would be the 7th one in. Yeah, that's the first one. That's the second one, except that the second one goes all the way up to 3 volts. Alright, so there's the next one. It looks like this. That might be the clock. Yeah, it looks like that's the clock there. And okay. Alright, so I don't really know what to make of that, except that apparently those pins here at the beginning, it looks like one of them is going to be the enable or the chip select line, which seems to always be low. One of them appears to be like a horizontal clock, and then the other one appears to be a vertical clock. So it seems to me like the LCD has just been pre-programmed to only, you know, take the clock lines and, you know, shift like the color data into, you know, like the respective pixels. So it doesn't look like the main chip, the controller here, is actually doing anything to do any setup on the LCD itself. It's like as if the LCD was already set up, and all it's doing is just taking the color data and then the bit clocks. So I guess, you know, maybe we can wire something up later on to just try to drive it and see if, you know, we can display something on it. Alright, next experiment. I hooked up a USB cord to that USB, or that little area right there that was apparently labeled USB. The 5 volt and the ground were pretty easy to figure out, but the two in the middle, I just kind of guessing at it because I have no idea if that's how they wired it in or not. But those two lines, the ones that are supposed to be for data, they go straight into that ASIC. So we're going to plug it in now and see if it does anything. USB here, we'll see if anything shows up. If nothing happens, I'll switch around the green and the white lines there and see if it does anything. I removed the video card for now, and let's plug in. Nothing showing up, so I guess not. So let's flip those around and see if we get anything different. Okay, test number 2. Flip them around, flip the green and white around, and see if that makes a difference. Nope, that doesn't do anything either. So I don't know, I guess maybe that's just not enabled or something. I was at least hoping that, you know, something would pop up there like saying, you know, it's detected something, but apparently not. And lastly, let's see if this little button up here labeled update does anything. It looks like it's supposed to short these two contacts here, so I'm just going to short them out with these tweezers. Let's see if anything comes up on screen. Apparently not. Yeah, nothing's changing. I don't know, maybe it's supposed to be shorted when you turn it on? Let's see, I'm gonna put the tweezers there. I'm gonna remove power, and then power it back up and see if it does anything. Nope. Well, let's try hook it up to USB now and see if anything happens. Whoa, hey, it did something. Except that it says USB device not recognized on there on the bottom. So I'm going to flip those lines over again and see if it does anything then. Okay, so I'm going to short out those that update button again. And I'm going to apply power to the unit. Okay, it's on. And now I'm going to plug in the USB and see if anything pops up there. Oh, shoot. Let's see what it comes up. Installed ready to use. It just says human interface device. I don't... Yeah, that's all it says. USB human interface device. Nothing specific. I would think maybe that it would say something else, but... Well, I guess it's something. I don't really know what we could do with that. But yeah, I guess that's how it works then. It's got to have that update button enabled, and then once you plug in the USB, that's when it recognizes it as something. It doesn't just recognize it if you plug it straight in. So, well, there's something new there. Alright, so now that we've had some fun poking around with the main unit, let's see what's inside this SD card. I think it shouldn't be too hard to open. It's like maybe we can just stick this blade in here and it... Oh, it's already popping open. That's easy. Oh my god. They just, looks like they just soldered this micro SD to the... Yeah, that's all it is. They just soldered this micro SD to this little adapter, and that's it. So I was maybe expecting something a little fancier. As I mentioned, I thought maybe this was like one whole assembly and then they just, you know, would snap this off if needed, but nope. That's it. Alright, well, I hope you found this kind of fun, just sitting here investigating with this little unit. Maybe in a future video I'll see if we can drive that LCD by itself. I might program like a little microcontroller or something and make it so that, you know, we can like feed in some color data and clock it. It appears that it's only using like the horizontal clock, and because when we checked it on the scope, like the horizontal clock was way faster, and I'm assuming that's a horizontal clock. Then the other clock was like a lot slower. So it looks like it's doing like maybe 480 clocks per every vertical clock. So we'll program something to maybe do like, you know, 480 clocks. I'll just bring the color lines out. We'll hook those up to like some dip switches or whatever just to mess with, or hook them up with something else. I don't know. And we'll see if we can make the LCD do something. So hope you like watching this. Remember to thumbs up if you like this kind of stuff, and see you guys next time.